Welcome to Vera Bullman's lecture. It's a great honor to have Vera back at the Bartlett after her first lecture in December as part of the BPRO, the first, in fact, BPRO theory lecture series. A few words about her work, perhaps, before leaving the center stage to her. Vera is a Swiss writer. She's a professor of architecture theory and the director of the Department of Architecture Theory and Philosophy at Vienna University of Technology. Prior to this appointment, she was at ETH, where she also ran a series of seminars and workshops on that were eventually turned into the Applied Virtuality book series. This is a crucial, I think, series of books that have come out in recent years on the digital, on technology, on issue of environment, issue of materiality, which have been really defining, I think, in terms of the kind of discourse and conversation that have been going on in recent years. Her background is one that comes from philosophy, from media studies, from literature. So she comes to, let's say, architecture from a very interesting and unusual angle. And also her work is particularly focusing on the work of Michel Serres, I think, that is a philosopher she is completing a book on. In fact, the book, which will be published by Bloomsbury in 2018, will be titled Information and Mathematics in the Philosophy of Michel Serres. Like I said, it's, tonight the lecture is a very promising one, as it promises a sort of a shift, if you like, of architectural theory from the paradigm of thermodynamics, and that's why Vera was quoting Latour in her brief description of the lecture, towards quantum and quantum physics as a kind of major, if you like, shift in architectural theory. It's also very important, I think, to have people like Vera, and part of the conversations that are going on at the Bartlett, at least for two main reasons. One is that there is content, obviously. Content always has to come first. And Vera is part of in fact, he's a leading theoretician in Europe, working with a number of sources and references in terms of computation and technology, which is really new and very interesting. So in that sense, it's part of a movement that is, let's say, emerging more and more clearly, in which the references of the computational are radically different from what we have read so far, coming perhaps from other geographical areas. The second thing is, of course, is Europe, and the importance of a number of theoreticians that are emerging in Europe discussing issues of design, computation, and technology. So I think these two elements are perhaps one of the most interesting things I find happening at the moment in terms of architectural theory and conversations. And obviously, to have a leading figure in these conversations is going to be very, very interesting. So I will leave now the stage to Vera, and please welcome her.
Thank you very much, Roberto, for this very kind introduction, and to Frédéric Micariou and Bob Shields for having me here, for inviting me. I'm very excited to talk today. It's one of my first talks, I must say, really to an exceptional architecture audience. As Roberto pointed out, my background originally had been literature, and I cannot completely get rid of these traces, but I decided today to speak for once completely free with slides, which is not something that I'm used to. Usually, I either speak completely free or I read a manuscript. I hope I will not get lost, but I need to grasp my notes. So the title I chose wants to focus on exhaustion. I gave it, it's almost the other way around. So the treatise on the current condition of architecture theory, I would like to say maybe first what it's not going to be. So it's not going to be concerned really in the modern sense with the condition of production of architecture or architecture theory. It's not going to be concerned a lot with mapping fields of architectural discourses, trying to take stock and to draw cartographies. I want to understand the notion of condition much more in the sense that we speak about our bodies as being in conditions. So, condition in a sense that comes in a certain way from the transcendental philosophy, so condition of possibility, of course, but which relates a lot to the question of what a body can do, as Spinoza puts it. And what I would like to speak about or to make as a bridge is an understanding to think about computational reason through the idea of what it might mean to have a body to think in, or a body of thinking. So condition is coming from this side, and that's also how I want to relate it to the topic of exhaustion. Then there's another word, well actually two other words that I need to point out maybe. I call it a treatise. So it's a handling. I am not presenting you a new theory. No? I believe one thing that the computational turn, let's say, or predominance really adds that is super interesting is to no longer think of theory in terms of one theory or another theory. So theory is active thought. I will of course come back to this. Then the third term is current. No? So I explicitly didn't want to say contemporary, although this would have matched quite well, but it's too much related to the discourses on modern or classical or postmodern. I want to speak of current in a physical sense, so what takes its course, a current like a river, like a flow that percolates. This is a notion that is very central in what I would like to talk about. So, exhausted is a term that Gilles Deleuze treated in a very, very interesting way in a short, well actually it's a series of short texts that was eventually published as a whole book on Samuel Beckett. On the notion of the absurd. The distinction that he foregrounds is to say to be exhausted is a whole lot different from being tired. It's not just tired. Tired we are after we do some exercises and our energies are exhausted, we say, so we feel tired. But what he wants to talk about in terms of exhaustion is related to what it means to possibilitate. That is a verb which struck me as quite helpful in the discussions between the actual, the virtual, the real, the possible, potentia, power, potency, and all of these distinctions that are so hard to sort out. To possibilitate requires that one tries the impossible. Deleuze quite straightforwardly says that the impossible should be asked of me. Good. What else could be asked of me? He talks about this with regards to Beckett, and he begins the text with a citation of a poem by Beckett, which is called What is the Word? He describes how Beckett, this is what fascinates him, how Beckett got more and more intolerant. He could no longer tolerate words. That is something which for a writer is quite awkward. No? So a writer who writes in a driven by an intolerance, an increasing intolerance towards words. Beckett expresses this through a lot of indexes. No? In this little piece, what is the word? We are always pointed to so many things. Folly, seeing all this, what is the word? This, here, and on it goes. Index, pointing out, making open connections which are not closed. What I am fascinated and would like to take further, to generalize in a certain way, is an understanding of the absurd, which quite literally, in the etymological sense, takes up the meaning of this word. It means absurd, what sounds from the bottom. No? What sounds from the bottom? Absurd. The bottom is usually in philosophy, of course, the domain of reason, of ground, of foundation, of stability. What this idea of exhaustion, in distinction to being tired, relates to is the bottom as well, but in a different register. I will come back to this later. So, the kind of exhaustion in relation to the absurd, in relation to reason, changes the idea of how we can think about thinking. So, the modern idea is that we have a faculty of thinking, or we have a threefold faculty of thinking. We have reason, we have imagination, we have memory. And as faculties, if we would then say they can be exhausted, they would be like stocks of energy. They would be like finite resources that can be completely known or completely mastered. So in order to avoid this, we began to speak with regards to computational reason, to artificial intelligence, as a body of thinking, at first quite metaphorically, quite figuratively. But more and more, I think there is a way to make this not only a metaphorical, but also a precise notion. So, as a bridge for you to understand what this body of thinking should be like, I put two images, which I'm sure you are quite familiar with. The one on the right-hand side quite nicely illustrates the absurd from one point of view, the cornucopia from the other point of view. No? If we don't go with the logical idea of the absurd, when it means you accept paradoxes, there are contradictions which cannot be resolved. So the ground cannot be settled. When we actually say there is something that can be sourced from the absurd, so that which sounds from the bottom can be captured. We can make it permanent. We can make it stay in a certain way. We can encapsulate it. A bit like, I will come back to this. So the idea is to think about what we do with photovoltaics. No? When we catch electricity, energy out of the air, put it into batteries, transform it into fuels, transform it into sugars, transform it into powering computers, all of these kinds of things. So this idea that today we have energy that literally is there, like the air is there. No? The sun is a source. It's not a resource. So that's a way to speak of sourcing, which doesn't lead to sorcery, to witchcraft, to magic, but it's quite concretely in a similar way, like in computing. I'm sure you have encountered this with the applications. We speak of sourcing data. And this is quite difficult to imagine. What should that mean? How can this be? Sourcing data. Is this being creative? Usually, that's not exactly what is meant with sourcing data. So this notion of the cipher here, in between, is a necessary mediator if we want to speak of a body of thinking that can be exhausted and that sources sounds from the absurd, from the infinitesimal. The cipher literally is a term which had been introduced in early Renaissance for zero, for nothing. So the cipher was crucial with the change in mathematics that began to count in what we call the integers. So that began to use a symbol in mathematics for nothing. This was, I'm sure as you know, a huge step in the development for science. And when we always speak today of the code, the relation to ciphers is not so often put to the foreground. And part of the puzzles we were reasoning in this book series that you mentioned with the Metalyticum had to do with this. So how can we think of a cipher that is not simply zero, but that can be there in many different ways? Because we have many different ways of saying nothing. Yeah, so that sounds almost comical, but it's one way to make sense of what algebra does. Algebra, we always have equations. So in principle, if you cancel out the terms, you end with zero. That's what it means to provide a solution for an equation. So you need to master the terms such that they produce nothing. And now the crazy thing is that depending on what kind of numbers we do this, whether we do it with the natural numbers, whether we do it with the real numbers, whether we do it with the computable numbers, as in the precise sense of Church and Turing, we have more and more ways of saying nothing precisely. Yeah? So a cipher is what sources code, if we look at it from this way. And when I was studying literature, I was always puzzled with Beckett because he was treated as an existentialist. But I could never see that. Not really. No? So, because he's obviously saying absurd things, treating the absurd in an extremely eloquent kind of way. And the more that I tried to find out about contemporary theories on the digital, the more I got aware of two things. One is that the digital is actually algebra, it's not calculus. Kind of falls out of consideration. There are very few people who address that. So the digital is treated in terms of calculation, of a calculus. But the form, the symbolic form in how it works is algebra. That's one thing. And the other thing is that what does it mean if we don't have one nothingness? No? If there are so many ways to say nothing and they are not coextensive. So this is a bit of a metaphysical gymnastics. And I can trust you, I can promise you that I'm not going to lead you to a certain theory, as I said in the beginning, with regards to these ideas. But this is quite puzzling and it's very stimulating, I find. Many nothings. All of them can be put in code. So then what does code do? How to think of this? And now I can maybe say why I chose the cornucopia. This comes from a discourse which at first looks completely unrelated. So it's a very, very central idea in the writings of Michel Serres, whom you have introduced a little. And Michel Serres is a philosopher, but he is a mathematician originally. So he always speaks of mathematics as a cornucopia. Mathematics gives us a cornucopia. Cornucopia is a horn of plenty. No? It's a horn of plenty. So when we actually have ciphers that can say in precise things nothing, and we think of it in terms of mathematics, then the idea I want to consider is to say these nothings, these articulated nothings, the ciphers, we can understand them as instruments. As instruments in the musical sense, this is where the term organ comes from, organon. Organon was, for a very long time, before the language game of faculties became established about thinking, people were writing organons to reflect on what thinking is. And an organon as an instrument which articulates nothing, this is the way how we can sound reason that allows to be sourced exhaustively, but in an exhaustive way that is exhausting. So it's not, we can never get it right. It wouldn't be absurd otherwise. We wouldn't be dealing with nothing. But we are dealing with nothing. So it can be exhausted, but we never reach the bottom. That is more or less the bridge I want to give you in the beginning. So another way to address the same, so squaring the circle, no, it's an impossibility. It's one of these impossibilities of which Deleuze says, of course, what else can be asked of us? Squaring the circle, doubling the cube is another one. So these are classical problems in mathematics that do not have a solution, but people have over all the centuries always found new tricks, new mechanical tricks to provide solutions. And doing this kind of absurd experiments has actually propelled the development of technology, of techniques, in an incredible kind of way. So, trying to solve what cannot possibly be solved once and for all is one way to think about the origin of mechanics and of techniques. And if we have this, then this cipher story, this nothing, also begins to make sense, because what is a mechanical device if not a device that can do and undo a certain thing? Yeah? So we have a mechanical device, we speak of a mechanism, if it produces something in a way that we can undo if we want. The whole story of differentiating processes, procedures, with what is called rationalization in industry, is about articulating in finer and finer ways mechanisms of how nature should work. So the instruments, that's why I make this detour with the cornucopia. They provide a way to think about technology, the role of technology today, that in a peculiar way has a direction, but is not predetermined. Yeah. So it has a direction, it makes sense, a bit like Beckett's literature. No? It does, so one cannot say it doesn't make sense. It's absurd, okay, but it does make sense. So it has a direction, sense literally means a direction, but at the same time, where it goes, this direction, so the end point, the goal or the telos, is not predetermined because it's sounding from the bottom of things. Yeah, that cannot be exhausted. So this is the idea of technology I would like to talk about. This is a citation from Michel Serres, which addresses, which helps to get more familiar with this idea to think of a body of thinking, but also our bodies, of course. We are used with the physical bodies, we are used to mechanistic analogies, yeah? But the point is how can we affirm a kind of a mechanistic analogy with regard to reasoning and to thinking? So what he says, he describes quite plainly the mystery of the body. Here are the sequences. I count, I practice. I end up being able. I don't know, I practice, I know, I don't understand. I practice, I understand. Until this moment, nothing new. Ordinary exercise, we could say, everyday procedure. But these diverse episodes conclude with another stranger one. I don't know a solution to this problem. What happens if we take on the task of doing the impossible? I don't know a solution to this problem. I practice. And then sometimes there is invention. So this thinking about technology, that's my core interest, is to provide a way to look at creativity, at invention, that is no longer either a subject philosophy related to particular gifts, talents. Well, it is, no, the cornucopia. It's the one of plenty. It gives gifts all the time. But it doesn't mean a notion of creativity from which somebody is gifted, someone is not. No, it's a kind of giftedness that can be learned. That's why I love this idea to think of mathematics as a cornucopia, because mathematics is probably the most radically impersonal way of thinking there is. Yeah? But this is complicated as well, because evidently it's hard to master. So for who? So where is the subject with regard to mathematics? I will come back to the mathematical side towards the end of the story. First, I would like to show you a little bit why, I mean, this is all, I love this kind of abstraction, so I like this kind of thinking, but I wouldn't invest so much in it if there weren't a physical reality in relation to it. So what does a body of thinking? It's a body, but it's not really personal. How can we think of that? So first, it allows us to address reason and thinking in a non-territorial way, but in a way of organization. And then there is one distinction which proves over the time more and more interesting. We call it the Republic and the Ecominic. I'm not sure whether these terms are really the right ones and the adequate ones. What they should express is when you have a circle. So a circle is the sign for the whole, for everything. You can be inside or you can be outside. If you try the impossible, if you go for the Horn of Plenty, you must claim a point in the outside to look at the horizon in the inside. That's one way to think about invention. But on the other hand, in order to do that, you must see a horizon. So this is when you are inside and you say, this is our situation. Here we want to think concrete. So you can delineate the horizon. You're interested in the limits, so the limits. Yeah. It's a bit like the squaring of the circle in the slide before. So what I am trying to tell you is not that the Republic or the Ecominic is good or not good. But if we think them, so if we try to think here, where would the squaring be? If we try to square this circle from the inside, we are working on giving more details to the horizon, let's say. Giving more details to the things we can grasp. Giving more details to the aspects with which we are familiar. More details, always more details. If we try to square the circle from the outside, we are thinking abstract. We generalize, we classify things that from the inside have a lot of particular distinctions. No? Both ways play together in a way that, for example, well, I'm not sure whether there are so many other examples as strong as this. Alberti wrote, among all his architectural texts, books on mathematics. One of them is entitled Ciphers. In fact, the writing that Alberti introduces here, first of all, gives us an understanding of his architectural thinking later, but it's also important to realize that the procedure which he invented had been state-of-the-art procedure for encrypting messages until the 19th century, which is quite astonishing. So what he invented is a mechanical way to encrypt, a way that you don't need to share a key because you have a device. It's a bit like a form of computing. So what he did is to have two plates that can be turned against each other, both of them with the letters of the alphabet. And to share a message that is encrypted, you just need to say an algorithm, how to turn the plates, where to start from, how many steps, and how many, the measures of these steps. So, with regard to thinking about language, this was super strange, because what it did is to consider the alphabet in a circular way. And the alphabet is, so alpha is the first, beta is the second, so the alphabet is almost the purest idea of a linearity that we could think. So the alphabet has always been thought in a linear kind of way. And then the analogy was that the alphabet is like tilling land, so it's like the plough that works the earth. So in the series about the alphabet in literacy studies, the alphabet is working our understanding like the farmer works the fields. So the alphabet makes our understanding receptive. It prepares it, it makes it fertile. It treats the land, it proceeds the land such that it can produce things. So what Alberti did was to break with this and say, no, I'm interested in looking at the alphabet, in what it can do if we decouple it from the earth, if we create a mechanical instrument for it, if we put it in a circular form, if we attend to periodicity, so to cycles, not to lines and verses and breaks and rhythms, to periodicity. 15th century. The other thing for which Alberti is famous is his inversion of the use of a particular instrument which was called the dioptra. So in architecture theory, one strange thing is that an entire book in Vitruve is on gnomons, so sun clocks. And the other thing is that for Alberti's thinking, the dioptra, the use of the dioptra was a tool, a device in astronomy for measuring the angles. It's like when you learn how to drive a boat today. I tried to do that, I didn't succeed. I quit before I got it. But when you are learning to drive a boat, you need to find orientation in a strange way. So you still use, on a boat, you use a dioptra to find the points of reference on the coast when you are on the lake. For me, it was always Lake Zurich, so it's not very big. So I didn't have to look at the stars. I could just look for the churches. But it's a manner of identifying your location in a non-absolute way, so in a way that is relative to where you are. What Alberti did is to take this instrument, the dioptra, with which usually, so it's a device you can look through, and then from comparing the points of reference in the stellar constellations, you can in relation to the Earth measures, you can identify your position. And what he did is to use this tool, but not to look at the skies, but to look from within the city space at the organization of the places. So it's a bit like when you learn to drive a boat. So he was looking with the dioptra at the different landmarks or points of reference of his choice, and through that he could plan, he could circulate the square order in a way that allowed him a different kind of vision. So the interesting thing about this is it always works through indexes. Indexes are points of reference of which you only have one half. Yeah? So an index points out but doesn't give you the conclusion of what it means. I'm sure you're very well familiar with this kind of thinking, much more than I am, probably. What I found very, very astonishing here is this sentence here. Yet a simple adjustment at the root of the trouble might change everything. So these are the opening lines of the preface to the Modulor. And what he is going to explain as an example of such an adjustment is the invention of the musical instrument by Pythagoras. So he's going to say, to think about how Pythagoras, when he heard that sound, no? If you are, I'm not sure, when you are not familiar with it, it's a very beautiful story. So the thing is, how did Pythagoras come to perceive or think that there is a harmonic sound, that there is something like harmony in sound? And the mythical story goes such that he heard what's the word? The person who they work iron with the amboss. So, and from the particular super extraordinary constellation of the masses, of the materials, of the pace, of the force that was used, Pythagoras perceived this sound. And this is the thing which I think distinguishes or begins to set science free from religion, which is also very rule-based, no, we can say, is to say, well, this sound, I don't want to know where it comes from. I don't want to build a temple here to celebrate that this was an extraordinary event. What I want to do is to come up with an instrument where I can get as close as possible to this idea, this perception, whatever it might have been. So how can I reproduce the phenomenon? How can I reproduce it? So the instrument that Pythagoras built was the monochord. The monochord was this one string which he began to cut in different sections. No? And he began to think how they play together. So what he eventually came up with is the chords. So the chords, it's a kind of a spectrum of how proportions play together, what sounds they produce. And this was at the basis of number theory. That's why Pythagoras is usually known today as the inventor of numbers. But he was an inventor in quite a mechanical sense of numbers. So there is the story with this instrument with it. And it is this example that Corbusier is introducing to start his book with. And he says what Pythagoras changed, his adjustment at the root of a phenomenon, such that he can learn to reproduce it. What it provided was the possibility to translate from the harmonic domain to the mathematical domain. So from an aesthetic domain to a mathematical one, from harmony to geometry. And he's saying that a step like this does not exist for treating distances. So we have an immediate relation to distances, and we need something similar to what Pythagoras did with relation to this phenomena of sound. So this is another citation by Michel Serre. It's very much related to the theme of the absurd and of instruments. It's a bit like Beckett. He is a writer, he loves language. He didn't become a mathematician, he lived his life as a writer. But what he says describes the contemporary is a substitution that takes place in which science eradicates language. And when I first read things like that by Michel Serres, this is when I was still in literature, I felt horrified. And a lot of my, especially teachers, severely disliked Michel Serres for something like this, to eradicate language. If we think this in the paradigm, no, not Alberti with the cipher disk, so not the code, not the computation paradigm, but the plough line. No? So what would it mean if language can no longer prepare the grounds for understanding? So to eradicate language, no, to pick up its roots, to provide for no etymology anymore. So if we think it in this term, this is a horrible message. And it is not how Serres thinks of it. So again, think of the image with the spiral and with the cornucopia as two inverses. No, both are absurd. Both are impossible. I'm not saying they're real. But from how they relate together through this game of ciphers, of articulating nothing, they provide a way to think of this substitution which happens here, of which he speaks, less fearfully, let's say. So what he concretely means by that is the condition, if we want, of contemporary science, which works by attributing data, so attributing a date to its objects. So contemporary physics counts its objects, and that means accounts for its objects in terms of the time since the origin, the Urknall. They have precise numbers for this. The way that it is calculated is through quantum physics. So it takes light speed. Through light speed, it calculates what is called half-life time of atomic materials. And then from the distribution of this, they can measure something like distance in time. Now, I'm sure you are familiar with contemporary speculative philosophy. So there was a book, especially by Quentin Meillassoux, which made a very strong case of what he called the arche fossile. So what he was saying there is this kind of science gives us positive evidence of things that have pre-existed before humans were there. Because this arche fossile, it's the big mystery that his philosophy is turning around. The thinking of the ciphers and the computation as something that can be addressed, that can be taken into account, so that the algebra is, even so it says nothing, is not transparent, because there are many ways of saying nothing. Yeah. The way Serres describes this is to say black boxes don't keep a secret in the dark. No? He says black boxes incorporate a materiality, which is incandescent. So it's not light and it's not dark. It has the possibility to fire up, incandescent. So it's an abstraction from either light or darkness into a quantum physical understanding of matter, where literally, so this sounds very abstract, so what does it concern us? But what it supports, these kinds of positivity, what it supports is that the notion of materials that we are actually dealing with today, they are on a quantum physical level cyclical, radiating cyclical. So it's not anymore the idea of passive versus active, matter is active in terms of quantum physics. Yeah? So it's active, it's radiating, and it's cyclical. So that's the relation I want to suggest as an image for thinking. Yeah? To relate this to ciphers, codes, the Alberti's dioptra, so the cipher disk. It doesn't mean that we have to become, so to consider, that's my point, to consider quantum physical understanding of material doesn't mean we all need to go work in the laboratories now on the subatomic level. It doesn't. It transports a different thinking of time and of space that can be addressed on any scale. Yeah? So one way to say what this places us with, the absurdity if you want, is to say we can think now about space as something that can accommodate time. That is the inversion of what people like Henri Bergson, for example, were criticizing. No? So in the modern understanding, it was always such that we can reason about time by saying it is ultimately organized in space. Yeah? So we can, like in the moving images in film, yeah? We have the illusion of time that passes through having frames put in succession. So what this attention to data suggests is the inversion of that. It's asking us to invent how we can think of space in a way that it can accommodate time, not the other way around. How can space accommodate time? And again, this would, and is, an absurdity. But think of the cornucopia and the absurd. That sounds from the bottom. The project I have chosen also for the cover image to my lecture is by a colleague from mine from ETH Zurich, Poltak Pandayatan. He is completing his PhD by studying quasicrystals. And quasicrystals, they're something that have, at least that propel the imagination very much towards this direction. So what he's fascinated with is to create crystalline structures which have locally varied orders. And then he's interested in the kinds of shadows they can cast in this project. He has a whole series. His website is up there. I can very much recommend to look at it. So my connection is that if black boxes contain incandescence, then how we design the black boxes. And I'm sure if you are interested in computation, you know that that's exactly what algorithms are. No? They're black boxes. So algorithms are algorithms. They're called algorithms because they provide a certain kind of black box, which we cannot entirely reason, but it produces results of a certain kind in a rule-based manner. So the analogy is to say the creation of the black boxes can actually be reflected in the shadows that it casts. Now, this is quite scary to break with this idea of the light and knowledge and so on. And I think it's not by coincidence that especially these two terms dominate discourses, I think increasingly so also in architecture, the Anthropocene, the Capitalocene. Now, if we create the black boxes, which then give us shadows, that means the level for reflection, well, it can be anything. So, is there complete arbitrariness? Is it like a notion of capital through money as the general equivalent? No. So the general equivalent money, the best, again, that I heard about it is by Michel Serre, who just says it stinks. Yeah, because nobody wants to have it, but everybody has it, and it accumulates a sense. But that's a complicated argument. I don't want to go there now. What I'm interested in is to say how this quantum physical thinking can finally get a different relation to stones. Stones, materials as stones. So stones have always been the example for the immobile, the immutable. No, mountains, nobody can transfer a mountain. So stones are the sign of permanence. Now we all live in electrified environments, but in many regards, how we actually ultimately organize our lives is still very much not through incandescence and black boxes, but through stones and fires. And we seek comfort from that. And we seek comfort in a secular kind of way. So our goods that we buy, that's the other term, capitalocene, so comfort devices. Comfort was always a religious term. No? Comfort means to not feel lost. Comfort is related to fear of death, let's say. That is another dimension why Serre's thinking is so crucial. So this quantum physical level, he says we need to address it in terms of an atomism, not because we have atomic bombs and that we have particle physics, but because philosophically atomism has always been a philosophy which is, before everything else, concerned with giving a way of dealing, of rationalizing the fear of death in antiquity. So if the regularity of forms, the casting of shadows, can be so inexhaustively reasonable, let's say, so absurd, it never stops, there can always more be sourced, then ornament, so the relation to decorum, to rules, to what could provide comfort, they cease to be organically connected with culture. I think it's in this way that Koolhaas addresses, next to the generic, a notion of chunk space. Minimum ornament, not wanting to engage with decorum. As a way, and this is the point, to minimize the shame of consumption. So seeking comfort, but not wanting to address it in what it is, and not having ways to deal with it. This topic is, well established. The key reference for it was, of course, Nietzsche, who began to speak of the genealogy of morality. If you are familiar with computational discourses in architecture through the Lambda, for example, I'm sure you have heard of the transformation that Deleuze and Guattari suggested when they say we have to speak of a geology of morals in terms of sedimentations. What I want to talk about is the agedness. So it's a kind of a material image, so it's a material notion of aging. That's what the story with the data, with the cipher, with the instruments for rationalizing, for keeping track of, for objectifying is all about. It's a notion of agedness, which I think we can relate to Nietzsche's question. No? When today, especially discourses around, let's say, transhumanism, singularity, cellular, so Wolfram's new universal science, this question of the 19th century is still here. So we don't articulate it very often, but learning has a lot to do with mimesis. But what are we trying to copy? What is science if it invents more and more, if it possibilitates? No? And this is what the computer is showing us. So more and more possibilities in every direction, more and more contingencies. Fewer things become stable, become habitual, become unquestionable. The question really is, where is this? How to think about where this is going. So this big concern with anthropocentrism, I think, is very much at the center of these questions. The answers we usually get are these. There are objective things that pre-concern us. Climate change, the limits of growth, Club of Rome, finite resources, consumption, waste, pollution, in short, the dominance of capital. So things are in agitation. You know, that is another, so the idea with the quantum physical view is very unsettling on the one hand, but on the other hand, it allows us to counter, to confront, to look at this agitation with a certain calm. Because it's normal, that we know from history of science, it's normal that a particular technological paradigm gives the tone for the reality of all institutional contexts. So dynamics, rationalization of processes, building of capitals in the late 18th, 19th century, you find it throughout all of the cultural domains. So this is stone thinking. This is stone thinking. When we think with the cornucopia and the ciphers and the cipher disk, this is no longer, well, it is absurd and it is impossible, but it's reasonable. So, to speak of the speed of a concept and a particular motion, and the position, the indeterminism that characterizes it. What Serre proposes is to, we need not go into details. I'm a bit too slow in proceeding. What he's basically saying is that the quantum physical thinking with this notion of black boxes and shadows doesn't mean it's a new cut. It's something like a second modernity or something like that. No. It's the multiplication of the classical thinking. So anamnesis is an explanation of how we can learn, not through copying, and so not through mimesis, so not through striving to be like a referent, but from remembering and articulating memory. So when he says this is like the many zeros, the only thing we have to change is not one process of anamnesis, but many, in the plural. And mathematics is the key to that for him. I'm talking about stones because stones have a lot to do with the story that Tafuri is talking about here. No? He's one of the few, as far as I am familiar with until now, of the few architecture theorists who is quite aware of a certain religious history that relates to hermeneutics, analysis, and community. So his question that I would like to take with us for a few slides is how to utilize this enormous power of analysis, of analytical thinking, without becoming, again, the instrument of a sacred rite. And this is in relation to the thinking about mathematics, because I think that is very, very important. So if we think about the process of substitution through mathematics, all the positions are always only placeholders. So there is never a thing in there. And that is the main difference to the religious backgrounds that Tafuri is talking about. So, every day, 10,000 times as much energy than all of humankind is currently using. The sun is a source. I wanted to speak about the condition of current architecture theory, also by reference to Hannah Arendt. And her book, The Human Condition, starts with Nietzsche's question. It starts with giving an account of the Apollo space mission, and it says, the human condition. How can we think about the human conditions once we look at the planet from outer space, and once we can propel science, learning, knowing, according to how we look at ourselves. From the space mission state, we have gone a long way. So we're not only giving photographs of the planet from outer space, we are providing digital models for the whole planet. And this idea to think, to learn to think of a way how space can accommodate time, rather than how time is counted in terms of space. This is what Serre postulates a new Ptolemaic term. Now this sounds strange, no? Aren't we having enough trouble with the Copernican term in terms of accepting that the Earth is not really the center of things? But the Ptolemaic view never really gave an explanation of the cosmos. It provided a model to locate positions. So the Ptolemaic models, they were very much like the GPS systems today, with the parallels of numbers, so coordinates in terms of numbers. This is how Ptolemaios began to draw maps of the Earth. It was a data-driven procedure. It was not geometrical. It was calculative. So like Alberti's cipher disk is of course generalized in today's cryptography. Ptolemaic models of identifying coordination without a point of origin, that is the point. With Ptolemaios, we can leave the Cartesian notion of an always already coordinated space. That is necessary if we want to accommodate time in it. No? So to say that the coordinated space has a zero means a beginning. So it has an absolute beginning. So if it has an absolute beginning, then time can only unfold in space. But we cannot put it back in there. So the Ptolemaic term doesn't mean to begin to affirm anthropocentrism and say, yes, all the rest doesn't matter. It's about humans on Earth. That's not at all the point. The point is actually to avoid that through saying, yes, what we are reasoning with are models of the world that center it. So how do they center it? Because they center it through encrypting the reference systems, encrypting spatialities, encrypting logistical relations, wherever you want to think of it. We can call this way of thinking about how space accommodates time. We don't need to invent how to talk. We need, but we have precursors. So the term from antiquity that very much related to something similar like this was called the meteora. every mechanical theory prior to Newton always understood itself in relation to the meteora. And the meteora is a term for which there are many definitions. Obviously, it relates to the weather, because the weather is universal, and yet it's different in every single location and every single point of time. So it's universal, but not uniform. It's a strange thing. Serre gives the definition of the meteora, which I found very graspable, very workable, as the sum of all measurable durations. Now, what this does is to say we have the language games of sum, of a total, of counting, in relation to measurement, and we don't need to have one dominate the other. We don't have to say, this again is a classical dispute about quantities. So a quantity is always made up of a unit and of a one. So a unit of measuring is a magnitude, and a unit of counting is a number. Magnitude and number. Every quantity is always both. And if you look through the philosophies of physics, you can very easily identify two camps. The ones which put number primary and the ones which put magnitude primary. Very often it goes in terms of materialisms versus idealisms. So this is an old problem. There is a lot to learn from history for an understanding of this notion of space which we are developing. So this is what, one of the slides I show to our students. I don't know what it looks like, but it's, I mean, there is this tradition, I never researched that, of monasteries in Greece. They were actually called meteoras. But they only became famous once the Christians inhabited them, but they are much, much, much older. And this prehistory of it would be super interesting to research. So, the more that I read of the modern architect texts, the more I find these questions around a quantum physical notion, a materiality of light, in the aesthetical theories, the more I find them inspiring in this way, which is very different from looking at these texts in terms of the production of norms and standards and neutrality and so on. So one way of making use of this cipher notion of the nothingness is precisely to become articulate about neutrality. Yeah. So that neutrality is not total and it's not absolute, but it can be counted and accounted for. So it's in a way conditional. And again, so I told you in the beginning, I don't want to do a philosophy lecture, but asking about this condition in terms of exhaustion and tiredness, sourcing and resources, has a lot to do with a transcendental approach. So to say that through a Ptolemaic term of modeling, so this is what I called in one of the early slides, ecumenic. So we are stepping beyond the horizon and bring something strange back. And with this strange thing that we bring back, the world looks different. We are sensing everything. Yeah? That's not a very long tradition. That's a few decades that we are actually sensing all this data. It's a few decades, and we need a paradigm to think what we are doing when we are doing this. And one way which I think harmonizes well with making a notion of the body of thinking so prominent is to say we are developing a kind of a proprioception, no? Proprioception for the earth as a body of living, thinking, being natural. We can then look at processes that we are well familiar with from chemistry, from crystallography, from all kinds of sciences, economy, storage, data banks. One of the crucial ideas in SER is to say the sun is the ultimate capital. No? And this is super troubling because it means capital is before actual value. So it relates to this indeterminacy, which I think is related to the Capitalocene, when people speak of the Capitalocene. So there is an indeterminateness prior to something to have meaning. So the point is, if we try to picture these abstract things like space that needs to accommodate time, then learning, the path for learning, is not one that needs to go straight forward, progressing. It's actually a retrograde movement. It's a retrograde movement that can learn from all the articulations in the past, because the assumption is that everything that is concentrated in its way of being theorized, in its way of being articulated, of being manifest in artifacts, of being written in texts, they are always thinking about time, space, presence, absence, expectation, taking into account, giving explanation, always this atomist presence of the fear of death, of the absurd, that which sounds from the bottom. So it is reasonable, but not completely so. Always about that. So we can learn from all these things. And these concepts are alive today, if we can make sense of them, for grasping these changes that we are experiencing. We are doing it technically. Yeah? So this is a way to think about these positions. So this is called doping. It's how substrates, chemical substrates, can be dispositioned to do certain chemical reactions. So to give a particular mixture of chemicals into such a substrate is how the printed foils that are everywhere in computation, also in solar, in photovoltaics, are there. We don't have lines, we don't have forms, we don't have containers here. It is something different. The paradigm of this technology, that's why I want to speak of sourcing, is different from taking from one place and putting it to another. It's like dew, no? Concentrating it, crystallizing it, extracting it out of the open air.
Range of printing options.
And it's massive production.
Several printing methods can be used.
So, again, the two images, square and circle, and we don't need to decide between the two. Yeah? We don't need to decide between the two. So usually that's another one of helpful distinctions if you look through the history of intellectual productions. Then you have people who favor the circle. They would call themselves realists. You have people who favor the square. They tend to the rationalist side. And then, of course, you have Baroque, where you think the square through the circle or the circle through the squares, and you don't make a distinction. So I'm not saying these are classification schemes, but these are gestures. If you look for whether somebody prioritizes circular thinking versus square thinking, you get a lot more of the gesture in which something is thought up, is made consistent. So, if it is all about nothing, between the square and the circle and the cornucopia, the horn of plenty, this fantastic thing, if it's all about the ciphers, the encryption and decoding of the nothing, then how to think about this relation, the rational and the real, let's say. So I put the cipher in between. Now, the realist would always say, yes, your rational order is very nice, but here comes. Yeah? The rationalist would always say, you say this is so singular, but look here, there is a regularity. So it goes hands and forth. It goes hands and forth. And one way to address this is to say there is a co-efficiency between the two. A co-efficiency, so efficiency, I'm sure you know as a term much better than co-efficiency. So efficiency means it produces something. It's almost a synonym to the term that Church and Turing use to define computability. Church and Turing define computability as effective calculability. So a calculation which triggers effects. So it's a mixture in Turing and Church already between a mathematical and a physical domain. So computability as it is defined by them is effective calculability. Coefficiency is a similar, addresses the same thing, but different from effective. Effective always means it's function, so it produces something. Coefficiency looks at the process of how something is produced. The mathematical term for this is equipollence as well. So an equation as a relation of equipollence. And equipollence involves value, also validity, power, and potency. So the domain of morals, the domain of logics, and the domain of physics. So we can think simply of nature and intellect as being coefficient with one another. One example of how to think of this, quite straightforward, is actually if we consider what we can do if energy is not scarce. So all of the problems with recycling, they're always related to the balance between using up stocks and therefore not being reasonable to invest into. But I don't want to speak about that. I want to come to computability now. So if we say there is a relation of co-efficiency between the real and the rational, and we consider the universe in terms of today's science, that means through age, through agedness. Things are universal if they have an agedness. So earlier we would have said an essence. We can say now purely formally an agedness. Then we must say there must be corresponding an agedness to reason too, because otherwise we have a domination. So rational and real must be coefficient, not one dominates the other. So the agedness of the universe must characterize rationality, but not dominate it. So both must be looked at through the same register. And how can we think of this? Now this goes back to the mathematical anamnesis in the plural. Because mathematics is, of course, not mathematics. So mathematics originally meant all that pertains to learning, intransitive. In mathematics, there never was a product. It was not related to a product. So mathematics, all that pertains to learning, and then inversely, of course, to what can be learned. And it's made up basically of these three things: arithmetics, algebra, geometry. So in arithmetics, we have basic operations: addition, subtraction, division, multiplication. Algebra is all about equations. Geometry, I would say, is all about projections. And the relation between these, they transform through the centuries. If you read, for example, in antiquity, if you read, what's his name, with the screw, the inventor of the screw, of the point, give me a point in the outside and I can, yeah, okay, sorry. Yeah, if you read the different mathematicians, you can always see, this is a bit like, does someone give prominence to the circle or to the square? Does someone give prominence to the view from the inside? Going into details, making the horizon spacious through being very detailed, or going to abstraction, coming from elsewhere, bringing with schemes that are strange. So these are distinctions, and in the history of mathematics you find this as well. And what in the 19th century was, that's why the early 20th century began with what is called the foundation crisis, was a huge, unsettled, yeah, we can say war in science between or about how to make sense of the new mathematics. The new mathematics, at the time, they were new numbers. Basically, the most unsettling thing was a unit which was called the imaginary unit. It's constitutive for the complex numbers. It's the square root of -1. And this is philosophically as unsettling as the absurd that we talked about, because if something is negative and you multiply it, it becomes positive. So to say there can be a square root of -1 means somehow to have stopped the process without fulfilling it, and then doing an operation upon going halfway. Yeah. So you can see this is, I would say again, this is an indexical kind of pointing out what can be counted. But what is important now is that these kinds of abstractions, they triggered on the one hand the new physics, electromagnetism, later on electricity, and on the other hand, they completely messed up the way to think about science and the organization of science and the hierarchy in terms of Erklärungshoheit. So having the role to actually give explanations. And in that time, as a reaction to that, there will be the slide afterwards I'm coming to. The arithmetics was made very dominant. So looking for foundations meant to have an arithmetical logics. And an arithmetical logic, so why would that even be, I'm not talking to you here now as a philosopher of mathematics, I'm trying to give you images to trigger the imagination. No? So arithmetics is counting numbers. It is also making any number out of any number. So it has a lot to do with all the numbers are in the one, or one is in all the other numbers. These kinds of metaphysical thinking. So it has a lot to do with narrativity. It has a lot to do with accountability. And logics has to do with being not historical. So logics is a form, and it takes us out of time as it passes. So what is logic doesn't count today and tomorrow not. Yeah. And this is how I understand what was happening at that time. Why this emphasis on arithmetics and logics? Because what we have in the physics of the time, so in thermodynamics and in quantum physics, is a passing. Time passes. Yeah. So it passes. And logics goes countercurrent. So we can say, we can articulate this from many in different gestures. If we are logicians, we would say our logics is never perfect. So it always dissolves. So there is a history of logics. But that's just because we don't get the point right. In this case as well, we have a countercurrent movement between time and logics. My personal position would be to say, no, time passes. And logics are like spaceships. They go against the stream. They're like a mechanical instrument. They give us ways to produce something and to reproduce it, because they give us the mathematical form to do so. But in any case, what this triggers, and that's quite surprising, is something like iconoclasms and orthodoxies within mathematics. So what we often hear, especially since the 60s, is that we have iconoclasms in art, we have it with regard to cultural products, to objects, and we need mathematics to sort it out. But what really happened, and that's not the first time in history that this happened in the 19th century, is that these kinds of struggles happen within mathematics. So it was about which numbers are accepted to do science with. So if you read this, it's very fascinating to read the original text from that period. And don't get scared, it's all about the devil, and it's about, algebra is always the devil. But of course, because algebra is equations, equations are formulas. Formulas are spells or witchcraft or devil or alchemy. So yes, it's nothing which is not nothing. But if we look at the mediating, at the facilitating role that ciphers provide, it needs not trouble us that much, because then algebra is no more formulaically odd than the diagonal is, if we are within squares. No. Okay. Yeah, we've been here. So learning which is intransitive. That's again, why speak of a body? Why consider a body of thinking? Because when we, especially with our bodies, we train, we exercise. We train and we exercise without wanting to achieve something directly. We bring us in shape. No? So we want to feel better in general when we eat healthy, when we go walking. So there is a kind of a transformation which is directed, but it's not determined. It doesn't fulfill an object. This is what I call literacy as well. Literacy doesn't mean to be super good in convincing someone or writing the most sensitive poetry. It means any of it. It means lying. It means making clear arguments. It means all of that. Literacy is immoral, if you want. But I would say the condition of possibility for morality. So mathematics as the intransitive object. Now, if we look at why, and that's my concern with the computability and the agedness. Why arithmetics? How am I doing with time? It's going too long, huh? I can make it short, actually. Yeah? So it's, I think, about 5, 6 more slides. So, this is a very helpful book which looks at philosophy of arithmetics. And that's always how to deal with these formulas of nothing. Yeah, so how to domesticate algebra, how to civilize algebra. So he puts the question quite straightforward. He says, how can we reconcile the inevitability of arithmetics? Because nobody doubts that within one particular algebra, 2 and 2 are always 4. No. So no matter what. But is the applicability of this thinking in techniques, is it universal? How can we think about that? The 2 main positions I want to foreground are both are from the end of the 19th century. One is Richard Dedekind. He was the main person who invented a clear concept of numbers. That's why they were looking for a logics that is arithmetical. So a concept is that is coming from logics. In mathematics, you didn't have concepts before. You had forms, you had fields, you had structures, you had all kinds of things, but not concepts. Richard Dedekind introduced the notion of concepts, and I say Richard Dedekind because there is one key publication by him. I'm sure there were other people inventing it around the same time, thinking in similar directions. I don't want to be a historian of mathematics, but it's called the Dedekind piano axiom when we are describing today what it means to have concepts in arithmetic. So this is what Dedekind invented, so it's a mathematician, very clearly so. But for him, he wrote this little book, what are numbers and what are they for? So I call this a mechanical perspective, like Pythagoras. So there are numbers, wow. So how to think of them? What is this? How to make instruments of it? His idea then is to say numbers are free creations of the human mind. That's going to become iconic for one camp, let's say. We're saying, of course, in mathematics we are being creative, just like we are in technology, just like we are with artifacts, just like we are in culture. Of course, mathematics is an inventive domain that preoccupies our thinking. This is completely inverse to Dedekind's contemporary, Gottlob Frege, who said, in arithmetics, we are not concerned with objects which we come to know as something alien from without through the medium of the senses, but with objects given directly to our reason and in its nearest kin, utterly transparent to it. So his point is to say, with regard to arithmetics, there is nothing inventive, nothing projective, nothing creative to it altogether, utterly transparent. This transparency, again, think of this strange thing, the cipher, the neutrality, the nothing that is articulated, that by which equations work, produce functions, can be plotted into functions. So Frege had to invent a metaphysics for this. He organized this order of objects which are utterly transparent vis-à-vis other kinds of objects, and he claimed there are three domains of things. The idea is a crucial one, and that is the point why it was really a crisis in science. With Dedekind, there is creativity. Whose creativity? Is this a subject philosophy? Is it the genius of one person? How to think of the subject with regard to an inventiveness in mathematics? And if we do, does that mean that there is knowledge is a property? How can universal knowledge, and mathematical knowledge is always universal, how can it be universal if it is somehow a property? This is what Frege was concerned with. And he said, in this third realm, that's why he makes this transparent role of arithmetic so central, we have a domain of objectivity that cannot be owned by anyone, because no one can invent and by intentionally dominate the number game, the number play, arithmetics. It cannot be dominated. With Dedekind, he's my hero. I like a lot what he's saying, and we need to make sense of it in a different way. So the beauty of the scheme I tried suggestively to talk about today, with the sourcing of the interplay between squaring the circle, circling the square, and having it represented in an instrumental kind of way through mathematical cornucopias. They don't try, like the monochord of Pythagoras, it didn't try to represent something. It was an instrument entirely devised for creating a certain effect, for approximating a certain phenomenon. It did not try to mimic nature. It did not try to represent something. It's an instrument made to produce an effect. So this is the cornucopia, and it can be mathematical. We can have mathematical, algorithmical black boxes like cornucopias to trigger certain effects. With that, we have a kind of an inventiveness which is not a proper ownership relationship, just like we always had it in mechanics. The mechanic must be smart, of course, but he cannot will one of his tools to work. It either works or it doesn't. Yeah? It's out of the arbitrary domination that would be entirely subjective. So a mechanic, you cannot will a water wheel to produce a stream of energy. You cannot will that, but you can do it if you can invent it. So there is, on the mechanical side, a way to think of knowledge that is produced like that, which is not a property, And that is different from the one that Frege is articulating here. What we have then with the mechanical side, and this I think is very interesting in his paradigm. So he speaks of the architectural equation. No? And he says, and that is a mix, no? I showed you before. So arithmetics, geometry, algebra. Elements, this is logics. Yeah? So he says there are elements and the architectural equation. He names the elements, but that's not the most interesting point. The most interesting point is that he says between these, well, what these elements do is within this paradigm here, communication. The communication of an original idea, and then it's a process between two players, an author and a receiver. But this anticipates, or this, whatever we want to describe it as, it certainly addresses a quantum physical notion of electronic communication. So a physics of communication, that's what I find attractive about the mechanical objectivity of producing knowledge, of affirming computation, and of doing not the foundation of a new age, not a new modernity, not a new paradigm. That is all not so interesting if we think in these terms, because like Godot, who is waiting, if you have all of the time and all of the means that you can only hope for, so if you're sitting in the horn of plenty, it is frustrating. So what's to do? So if anything is possible, there's probably nothing more deadening to inspiration than if anything is possible. If anything is possible, who can have an idea? And what would even be an idea? It's all pointless. It's entropic, it's generic, it's indistinct. So how to make distinctions, how to place values, how can one even have ideas if you are sitting in the horn of plenty? So that's not very interesting. What is interesting is to source from history. So to see how time is actually accommodated in space, in our objective notions of reasoning. So to reread these texts, these artifacts, to look at Alberti with his dioptra, not only from the point of view of becoming an author in architecture and going into an abstract model space, but no, how is this model space? Where is it coming from? So try to source, do a kind of an archaeology with this. That is my interest. And we can do this mathematically. So it's really a science of history, because it's not tied to the deeds done by important persons. Now, I'm sure these kinds of transformations that now we have the image of Alberti, and Alberti is very prominent and very important, but I'm very sure if historians go looking, there are many other people, contemporary more or less, that have a similar kind of inclination. So this is not about creating a proper, well, yeah, data. Yeah, I think I had this before. So the two ideas that I hope I could somehow stimulatingly talk about now, I'm sure I was not at all very, very clear. I hope some things were quite clear. The two ideas that I find super interesting are to distinguish this movement of possibilitation and the movement of realization. Now you could say, if we say time and logics go countercurrent, if we are in logics, what we are concerned with is to possibilitate. And again, if we are sitting in mathematics, it's pointless to go to logics alone, because how can we, so we are, and this is, yeah, I don't have the citation now from Deleuze with which I started. No? So Deleuze is all about, if I am exhausted, I can no longer possibilitate. So, and exhausted is the one who sits in the horn of plenty, who hears only what sounds from the bottom. He knows it can be reasoned, but how so? too tired, too much, too generic. So the exhausted can no longer possibilitate. So in a way, he's completely real. Today we would say he's super global. He really doesn't want to be traditional anymore, or she, yeah? He doesn't want to belong, doesn't want to have an identity, live in the whole world, breathe in the networks of the electric social community, whatever. So be not, well, in a way, be entirely real through that. So no rationalization. So you're exhausted. On the other hand, if you try to order stuff, you need inspiration too. So if you take into account that time dissolves, so this, the reason why I had this image with the sunstorm, if you remember, that was hanging a bit in the air. So it's an image of death. That's how I wanted to bring it. So it's a way of speaking about this incandescence, which, no, and that's from the point of view of the mechanic, and that is the thing with tafuri, and becoming the instrument of a sacred rite. So if science eradicates language, because substitution, there is a substitution taking place. The substitution in terms of a mechanical thinking always is about producing it and undoing it. So producing it and undoing it. That's why I think this idea is very, very actually relaxing compared to the foundational crisis that you have when you read the people around 1880 and 1920, let's say. If you read, and not only the philosophers, the physicists, the chemists, the biologists, almost everyone. This is another form of agitation which is, yeah, different from the one that we have now, I think. Now we have like a micromolecular agitation, and in that time you have massive agitation. And it turned out in that way, no? We had very, very horrible wars. They have a lot to do with the role of intellectuality. So I think there is a, okay, but we don't need to go there. What I would like to give you is this tool, so to possibilitate and to realize. No, so to have logics and time. So time is so the real, yes. So we can think up orders and then something we haven't taken into account, of course. But it doesn't annihilate the order. So it doesn't, so the order cannot dominate it, but still it can domesticate. It can domesticate a lot of what happens. And with regard to what we, in a modern sense, always talk about as disciplines, we can say, yes, it's disciplines, but in the sense of exercises, with the exhaustiveness, yeah, with the bodies of thinking, yes, disciplines, but not disciplines that are object-defined. So we can think of them tautologically, because through time that passes, tautology is not vain. No? The same, so one thing in terms of itself has reflected upon it. So you always keep track with what you are. It's a different way of thinking about identity. So I would say it's not about the hierarchy between. So if there is something, there is profession in one field, whether it be music or literature or architecture or physics or philosophy or economy, self-reference. And of course, this is the ciphers. We have many ciphers. We have many neutrality. So every one of these equations can be considered in relation to its own neutrality and grow from that. So no new agenda. It's not about organizing masses towards a new goal. It's not about finally breaking with tradition or finally coming back to tradition. I would say it's simply about what it has always been, architecture. And these are the references. If you are interested, I'd be very happy to also provide you with PDFs, actually, if you are interested. The one book by Michel Serre, it's coming out later this year, hopefully September or October. But on my academia page are a lot of the texts free for download, sometimes not in the final versions. Thank you very much.
Thank you very much. Thank you very much, Vera. As promised, the lecture did put the rug under our feet and made us look at, let's say, conversations we have quite daily with a very different point of view, which I think is really the outstanding kind of quality that your work brings to the discipline. I just have a question to start. Obviously, don't have to be the only person to ask questions. It's on Alberti, and although you were saying that we don't have to necessarily put all the weight for a certain kind of transformation to a single individual, obviously that is the example you chose. And I was actually wondering about other Renaissance thinkers, and they're, if you like, more playful. I don't know if that's a good way to also describe the instrument, way in which they handled numbers, combinatorial logics and things like that. And I'm actually thinking of Pico della Mirandola. And I was wondering, let's say Alberti, as you said, sits in a certain position in how architects have always discussed his work. Pico doesn't sit anywhere in the history of architecture, but is a very interesting free thinker, if you like, with the playfulness of the numbers you also made later on, much later on in time, of course.
Yes, I can only support. Pico della Mirandola is, so what he did is super fascinating. So today it's called idiosyncrasy. Yeah. So his method was idiosyncratic. Today this is not a nice word. If somebody tells you that, usually they don't want to be very friendly to you. But there is something very, very beautiful about idiosyncrasy, and this is what Pico did. So Pico lived very early in Renaissance. He died, I think, before he was 30, very young. He wanted to get a PhD in a time when the universities were very, very much in the hands of the clerics, so of the churches, and of the scholastics. So a very, very canonic form of organizing the transmission of knowledge. So what it meant at his time to acquire a PhD meant to pick one super, super specialized kind of question about which there is a huge body of literature that you have to position yourself in relation to. No? So you can hardly say anything at all, because you have to answer to all these many, many important people who have already said that. So it's a kind of a still stand. That's also this energy which then exploded with the Renaissance, has a lot to do with breaking with this super canonical form of organization. So what Pico did, he said, I'm not treating one problem, I'm treating, I think, 96. Huh? So 96 of these problems. This was a monstrous kind of thing. That's like, so it's a generalist attitude. And then he invited, because who would receive this? Who would take this? So his idea was to invite at his own expense all these important scholars to come visit him in Pisa, Florence was it? Yeah. And to deliver to them a speech why it is not threatening to their position, what he is doing. And this is a speech which became super important. It's called On the Dignity, on Human Dignity. And it related, so the point was, it always has been mathematics and theology, how to relate. So mathematics is about the rational and the infinite. Theology is about the rational and the infinite, but in very different ways. So how to relate the two? What Pico said is, we need to relate between the two in a way that gives a scope of dignity for human thought. So that's the beginning of the humanist tradition, of saying we need to treat knowledge not in terms of ultimate or basic or foundational answers. We need to learn how to make them speak to each other, how to have them converse with each other, how to make contracts, if you want. And yes, very much. But there are others as well. I'm not yet so well familiar with the Tractati, but there are, for example, I'm very interested to look in Filarete and the notion of the body, and even in Vitruve and the notion of the body. And I think with this mechanical and the relation always to the instruments that help you position. So find a position. So not assuming a predefined order, but to think of it. It's constitutive for every one of those treatises. So it should be possible to look at every one of them in an interesting, different kind of way. So it's in a computational way, but not like many of, it's not about proving that a certain grammar has already been there in the early Renaissance, or proving that a certain syntax now has actually the authority of a long. So it's not in this spirit, exactly not in this spirit, in the idiosyncratic spirit.
Yeah, I think there's a good historians of science that wrote an interesting book over that period. The book is titled Clavis Universalis, no? Which is obviously the computational project of the Renaissance. In describing his journey through those, he says it's not about justifying the present. It's about to discover what is wrong with the present. Mm-hmm. So in a way, it's also not a problem. It's not a philological problem in itself. Yeah. Mm-hmm. So next project probably. Mm-hmm.
And we had, in the conference we did in December, we had an actor reading the whole piece by Pico della Mirandola. It's 1.5 hours, but it's very, very beautifully read. So it's online on YouTube. You can listen to it, and it helps also to relate. I think it's easier to listen to than to read, because in reading it's at times very, very distant. Yeah.
Yes. Any questions?
Thank you for this very extensive talk, and even don't know where to start, because it's like so full of new and very provocative thoughts. I start with like the idea that space accommodates time is of course like sitting a few hundred meters from the British Library, or distinct from the British Library, like the idea of labor, the idea of like the product, or like having a product which accommodates or like is produced with time. Uh-huh. So it's of course like turning something into a commodity is always what was driving a lot of like architecture discourse, like the way thinking of what production, and you like then you also said like there's the way of realizing things, or like then the way of domestication. And of course, this is in ways also is something very much also looking external to that what you saying as a principle. So not only having thinking this one of a way of disposition, but very much more in a plurality of this image what you draw as with the circle and the square. So have you some thoughts on extending these into kind of like more compositional issues, or like something which is external to seeing this as always like one principle?
I'm not sure I understood correctly. So are you asking whether it's going towards a kind of a design method?
Halfly yes, but more it's very much it's always like thinking in a more conceptual or procedural way, that you like in understanding how one thing is made, or like same like also like then in a way like an equation. And like in architecture, you have always, it's always like more than having this like thinking of the consistence of one thing.
I'm not, so I think it can be, so for me this is, it's not so much about stating principles actually. It's about a literacy and of having a kind of an idea where we are with this. No? But then it's a bit like, maybe I'm not understanding you right. But I feel like what you are asking is almost as if somebody is thinking about language and then asked to have a specific one for a particular problem. And there I would say, but that's exactly where I want to get out of. No? So, and with regard to information, it's very much like that actually. So people say information, so everybody would say, yes, it's all about communication, it's all about marketing, it's all about information today, but then we have a different notion of information in linguistics, and then in the different branches of linguistics, we have again a different one in medicine, we have a different one in chemistry, we have a different one in physics, we have different notions, so disciplinary notions that are dominated by academic communities that control certain fields and that try to profile to each other. And my interest is to overcome this. That's why I find it a beautiful statement that science eradicates language. Yeah. So also with this, so we need to find an understanding of these terms. Also computability, also mediation is another one of these. Communication, which are not territorially dominated. Because then if they are territorially dominated, we don't need to speak of these abstract terms. We can revert to an old vocabulary which would be more precise. So I'm not sure whether this is what you are asking. So I think it works in one way but not in the other. So it works, so with this kind of thinking of certain, I mean, I am coming from working with texts mainly. That's why it is there that I can unlock these kinds of perspectives. But when I visit, for example, with my partner, who is an architect, when I visit cities, he looks at the way the cables are organized, the way how the fences are put. He looks at all these spatial things, just like I look at literature. So with this thinking, he finds completely unexpected ways to characterize situations. But that is not my literacy, so I cannot do that now. I hope, I'm sure I learn a lot more about this now that I am in architecture, since 1.5 years, really, in architecture theory. But I cannot do it yet. But it's I want to say it's an example of how this thinking. So wherever you have your literacy, wherever you can do, you can unlock your usual phenomena in different ways with it, and that's the beauty of it not being territorial, not being administrated primarily, but being mathematical.
Well, I'm a designer. I don't know if my question goes directly to the point, but emerge from a kind of coincidence. So I'm a designer, work on computation, but before studying architecture or engineering, I did drama school. And actually I was working with Beckett quite a lot. And as a matter of coincidence, yesterday I was trying to trace a relationship between what I'm doing.
Maybe try this one. This one should work. Okay.
So yesterday I was reflecting on the fact that for me, when I was working with drama, Beckett was a way of I mean, I was very young, but it was a way of using the artistic dimension to somehow remetabolize human glitches, we could call it. And then I went to look for the definition of absurdism, and I end up on this definition that says that the absurd is a way to define the conflict between the human tendency to seek inherent value and meaning in life and the human ability to find any. In this context, absurd does not mean logically impossible, but rather humanly impossible. And then made me think about the language of machine, or that emerged by algorithms, that are languages that are humanly impossible. Maybe they're not logically impossible, but they are humanly impossible to understand. They have an inhuman dimension. Do you see this as correlated to your idea of logic, or is a totally different logic that is discussed here?
Well, I would, I mean, that's one, so in a way to say, well, that's one of the complicated things in philosophy, to say, so if you have a subject philosophy point of view, then they would say, well, logic is strictly correlated to human nature. So there is no distinction between the two. And I don't share this point of view. Yeah. So part of why the information as a physical and a mathematical concept is so attractive to me is exactly because it combines the subjective and the objective point of views. And that's why it must be an atomism. An atomism always means you have, there is a mixed thing and then it's broken into parts. So I wouldn't, of course one can look at it like that, yeah? So then it's an existentialist text which helps us to identify the place of humans in the universe, yeah, as a relativized kind of space. So then it's the same story that Freud is telling, you know, we are no longer masters in our own house, so our consciousness is not what really determines us, so there are other processes. So there were many versions of this same story, and yes, of course, that has a lot to it. I'm interested in leaving it with the way that I was now relating to it, but that is not at all to say I'm not claiming this is how Beckett meant it, not at all. So for me, and that has always been so in literature, there is, like now, like with artifacts, there is an autonomy to the thing. You know? So the thing is articulated in a certain way, which is manifest. It's there, and yes, it absorbs projections by the mechanic, by the author, by the architect, whoever. Yes, it does that, but it is not. I refuse to have it dominated by that, because we never think alone. Yeah. But that is not the same as to say the human and the universal science, they're completely categorically different, which is what you were reciting.
Trying to understand how this definition could eventually help in defining a form of language or machine that we could live or interact with. And I was trying to source different definition of absurdity, but it's actually something I started yesterday by total coincidence, so I was, yeah. But I had the impression while you were speaking that your definition of logic was different from this one, and I was not sure about this, so yeah,
okay.
Wasn't obtained to evolve it.
Yeah. I think, so I put the cipher in the center because I don't think, so we are used now to a certain relation to language, but I don't think we understand this any better than really, so in terms of a logic, so in terms of truth, in terms of meaning, of positive extension, we are just used. Our brains are, I mean, if you remember when you learned how to read and write, how painful it was. These many years, when you write, you take the form of the characters, and now when I look at the page with text, blop, it's in my head, so my neurons connected, so I learned it. Yeah, but ultimately, I don't think it's any less alien. We just don't have literacy with it. So I don't think it's a question of finding one particular form and language that would be connectable to humans versus others which are not. I think this is not a productive way to relate to machines. But this is the difficult thing, because in the 19th century it was all about saying language and mathematics, they are two different things.
Well, I was trying to trace a correlation also to the idea of meta-language of Platon, and now language is composed of a logical language and a meta-language, and how this could help
Okay.
a larger comprehension
Okay.
of
No,
reality. So for me, absurdity was a way of going elsewhere to reconnect to the here and now in some form.
So, but that's a good key, because I would say where I place the ciphers is where in logicist discourses you have meta-languages. So the ciphers replace, when I'm saying science eradicates language through a substitution, this substitution, I want to look at it through the point of view of a structural point of view, if you want. So the point of view of the key of this. So this is the cipher. Whereas a meta-language is a reflective domain that looks back in a way. So they are not compatible. So the ciphers that I was talking about can not make sense if you organize your thinking in terms of meta-language. But if you can put meta-language as a gesture in front of you, then it helps a lot to think of what the cipher can do. So in that sense, it's actually very helpful.
So now my effort was to try, because Platon is still in bracket a scientific author, was trying to look for absurdism or surrealism as other type of author could enable a different vision, a sort of elsewhere, rather than the sort of anthropology scientific point of view. Though discussing meta-language, which for me is a very interesting paradigm, is still inside of a certain paradigm.
No, for me, this is what literature does.
Yeah.
So it's always an elsewhere.
Yeah.
But it's never so it doesn't try to be an ultimate point or a first point. It's not necessarily a utopia, but it's always an elsewhere, because you're never really writing it about yourself, even though of course you are writing it about yourself. And when you're reading it, you're not reading about yourself, but of course you're reading about yourself. So it plays that cipher game. Literature is that. I wanted to show the slide with the arable land. But then I thought, no, this is too pathetic. But I was going to call it the literary land because of that. Yeah, nice. Thank you.
Any final question? No? Well then, please join me in thanking Vera one more time for her.